Our universe is constantly expanding, making it incredibly difficult to define its limits or measure its full size. However, thanks to the James Webb Space Telescope, we are now able to peer into the farthest corners of the cosmos. Since the telescope began its mission, numerous scientists, including Brian Cox, have shared astonishing findings about the sheer scale of the universe, its vastness almost beyond human comprehension. Within the observable portion of the universe, there are an estimated 2 trillion galaxies, based on studies of the local universe. Yet, we believe this visible slice is just a small fraction of a possibly infinite cosmos. We are not separate from the universe but are a part of it. Indeed, we are the means through which the universe becomes aware of itself. With the help of the James Webb Telescope, we are embarking on an extraordinary journey to discover the true extent of the universe. For those fascinated by such discoveries, subscribing to updates can be a gateway to staying informed. To understand the vastness of space, consider this: traveling at 70 miles per hour, it would take about 15 days to circle Earth's equator, around 5 months to reach the Moon, 63 years to reach Mars at its closest point, and an incredible 4,400 years to get to Neptune. These figures alone illustrate how vast our own solar system is. Take the Voyager 1 probe, launched in 1977. It traveled at 38,000 miles per hour and didn't leave the solar system until 2012, 35 years later. Even light, which can circle Earth 7 times in 1 second, appears slow when compared to cosmic distances. Our massive solar system is still dwarfed by the Milky Way galaxy, which contains about 300 billion stars, many with their own planets. Our nearest neighboring star, Alpha Centauri, is 4.3 light-years away, meaning that even traveling at the speed of light, it would take over 4 years to reach. At Voyager's speed, that same journey would take 70,000 years, an astonishing reminder of how immense interstellar distances truly are. Now consider Velt Rouge, a star located 640 light-years from Earth. If you observe it in the night sky, the light you see began its journey from the star's surface about 640 years ago, roughly a century before Columbus reached the Americas. Our radio transmissions, degraded over distance, have so far reached approximately 15,000 star systems, a minuscule portion compared to the hundreds of billions within the Milky Way. To comprehend the scale, imagine reducing our solar system to the size of a quarter placed on a map of the United States. Then, the Milky Way would be as vast as the entire Earth. Within this immense region lie 300 billion star systems, each potentially hosting life-bearing planets. Beyond our galaxy, there are at least 1 trillion more galaxies. To visualize 1 trillion, picture 1,000 cats. Now imagine 1,000 groups of 1,000 cats, giving 1 million. Then imagine 1 million groups of 1 million cats. That's 1 trillion. Our neighboring galaxy, Andromeda, is 2.5 million light-years away and moving toward us at great speed. It contains around 1 trillion stars and will eventually collide with the Milky Way. Despite the enormity of both galaxies, the chance of any 2 stars colliding is extremely small, illustrating just how vast and sparsely populated space truly is. Galactic collisions, while appearing catastrophic, may actually contribute to the formation and exchange of life-supporting materials across star systems. Galaxies themselves are dynamic and constantly evolving. As we move outward, we encounter not just individual galaxies but groups. Our local group, then the Virgo cluster, which contains over 1,500 galaxies. This cluster is part of the much larger Laniakea supercluster, home to about 100,000 galaxies, each containing hundreds of billions of stars and planets. And even Laniakea is just a part of a much grander structure. The observable universe includes around 10 million more superclusters. As we map these celestial bodies, we find an increasing number of galaxies, but these mapped ones still represent only a fraction of what's truly out there. There are countless galaxies we haven't yet discovered. Adding to this cosmic mystery is the cosmic microwave background radiation, the oldest light we can detect, a remnant of the Big Bang that marks the early stages of the universe. Zooming out even further, we find cosmic voids, massive regions spanning hundreds of millions of light-years where matter is sparse. These seemingly empty areas could one day give rise to future galaxies and structures. Threading through this vast emptiness are cosmic filaments, colossal strands of gas, dust, and dark matter stretching across billions of light-years, connecting galaxies and clusters. These filaments form a massive web-like structure, the so-called cosmic web, through which galaxies interact gravitationally. Matter in the universe is not evenly distributed but organized along this vast, interconnected web. It is within this tapestry that galaxies gather and evolve. Space provides an incredible stage for countless celestial phenomena. Supernovae distribute heavy elements, black holes shape galactic evolution and emit energy jets across the cosmos, and quasars, supermassive black holes devouring matter, shine as some of the brightest objects in the universe. All these reveal the profound complexity and awe-inspiring scale of the cosmos, a realm that continues to captivate humanity's imagination and curiosity. Quasars, those extraordinarily energetic phenomena, emit colossal amounts of energy, so much that they can outshine entire galaxies. These cosmic beacons illuminate the early universe, giving scientists a window into its formative epochs. Yet, this observation invites a profound question. What lies beyond the observable universe? Countless additional galaxies exist beyond our visual horizon, but their light hasn't had enough time to reach us. Due to the universe's ongoing expansion and the constant movement of galaxies, much of this light never will. This means vast regions of the cosmos may remain forever inaccessible. Based on our current understanding of physics, we can infer that the total universe is at least 250 times larger than what we can observe. Some theories even propose that it might be infinite. These staggering possibilities prompt us to reflect not only on the scale of the universe but also on our place within it. As humans on a small planet in a remote corner of the cosmos, contemplating these vast realities challenges us to ponder our role in the grand cosmic story. If you've ever wondered just how vast our universe is, hopefully, this exploration has helped you grasp at least a fraction of its immensity. Use the comments to share your questions, and if you enjoyed this content, don't forget to like, share, and subscribe so you won't miss more awe-inspiring discoveries. As we continue our journey through the universe, it's essential to recognize that our understanding is constantly evolving. Instruments like the James Webb Space Telescope have opened up vistas once relegated to science fiction. These tools let us peer deep into the early universe and even analyze the atmospheres of distant exoplanets, planets that might harbor life. Astronomers have now identified thousands of exoplanets orbiting distant stars, many within the habitable zone, regions where liquid water might exist. Some are Earth-like, while others are gas giants or icy worlds with hidden oceans. With billions of such planets potentially existing in just our galaxy, the conditions for life may be more common than previously thought. But our curiosity doesn't stop at the search for life. The universe holds even greater mysteries, such as dark matter and dark energy, which together make up about 95% of the universe's total mass energy content. Dark matter helps shape galaxies and cosmic structures, while dark energy is thought to be behind the universe's accelerating expansion. Yet, both remain largely invisible and theoretical. Adding to this complexity is the mind-bending concept of the multiverse, the idea that our universe might be one among an infinite number, each with its own laws of physics, dimensions, and possibilities. While still speculative, the multiverse theory offers a breathtaking perspective on what might exist beyond our own cosmic bubble. And then, there's time itself, a fluid, relative dimension as Einstein's theory of relativity reveals. Near massive objects like black holes, time slows dramatically, a phenomenon confirmed by experiments. This has deep implications for space travel and our understanding of the universe's fabric. Black holes, far from being mere cosmic vacuum cleaners, are engines of extreme physics. Supermassive black holes, millions or billions of times the mass of our Sun, sit at the centers of galaxies, influencing their evolution, regulating star formation, and unleashing powerful jets of energy that stretch across space. Even more speculative are wormholes, hypothetical tunnels through spacetime that could theoretically connect distant parts of the universe or even different universes entirely. Though plagued with stability issues, wormholes remain a tantalizing focus of both scientific inquiry and science fiction. Amid all this vastness and complexity, here we are, a curious species on a small, rocky planet orbiting a rather ordinary star. Yet we possess the remarkable ability to ask the biggest questions, build tools to explore the stars, and imagine realities beyond our reach. Each image from a space telescope, every whisper of radio waves from across the galaxy, and each particle tracked in underground labs, these are the ways we inch forward, illuminating the cosmic dark with knowledge. When we gaze up at the stars, we're not just seeing light, we're peering into the past, into the very structure of spacetime, into the heart of mysteries still waiting to be unraveled. The universe is not only vast, it's a mirror of our insatiable curiosity and our relentless drive to understand.